This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Topic 2 of Week 6, Engineering Economics Part 2. Last time we learned to move money across time with the 6 factors. Now we use them to decide which of 2 projects is cheaper, how an asset loses book value, and where revenue finally covers cost. Present worth, annual cost, rate of return, depreciation, and break-even. The tools that turn a cash flow diagram into a decision. Once the cash flows are drawn, one rule governs everything. Compare alternatives over the same service life. 3 methods do it. Present worth discounts every flow to a single amount at time 0. Lowest cost wins, but the lives must match. Equivalent uniform annual cost converts everything to a level yearly figure, using the capital recovery and sinking fund factors, which handles unequal lives directly. Rate of return is the interest rate that zeros net present worth. Accept it if it beats your minimum attractive rate. Applied correctly, all 3 agree. Pick the one with the cleanest numbers. Rate of return has one trap. Never just pick the alternative with the higher individual return. A cheap project can show a great percentage on a tiny investment and still be the wrong choice. Instead, do incremental analysis. Rank by first cost, lowest first. Form the increment, the higher cost options cash flows minus the lower cost options. Solve for the rate that zeros the increment's present worth. If that incremental return beats your minimum attractive rate, the extra money is well spent, so take the more expensive option. Otherwise, stay cheap. One question: does the extra spending earn at least your target rate? Depreciation is the bookkeeping loss of an asset's value over its recovery life, from first cost down towards salvage. The Handbook lists 4 methods. Straight line spreads the depreciable amount evenly, the same charge every year, so book value falls in a straight line. Double declining balance and sum of years digits are accelerated, bigger write-offs early. And the Modified Accelerated Cost Recovery System, MACRS, reads a tabulated factor for the assets class and multiplies it by the full first cost, ignoring salvage entirely. Break-even is the point where revenue finally equals the total cost of earning it. Split cost into a fixed part and a variable part per unit, and sell at some price per unit. Set total cost equal to total revenue, and the break-even quantity is fixed cost divided by price minus variable cost, the contribution margin. Below that quantity, you lose money. Above it, you profit. The same trick compares 2 alternatives. Set their cost expressions equal and solve for the usage level where the cheaper option flips. Break-even asks how many units. Payback asks how long. The notation. Comparison problems run on present worth, the annual amount, the interest rate, and the life. Depreciation adds first cost, salvage, the yearly depreciation, and book value. The interest rate here is your minimum attractive rate of return, the hurdle every dollar must clear. And every annual cost term is built from last topic's capital recovery and sinking fund factors. Worked problem. 2 pumps do the same job over 10 years at a minimum attractive rate of 8%. Pump A costs $50,000 upfront, $9,000 a year to run, and keeps $10,000 salvage. Pump B is cheaper to buy at $30,000, but costs $13,000 a year and salvages $5,000. Equal 10-year lives, so compare them on annual cost and pick the lower. Annual cost converts first cost to a yearly charge with the capital recovery factor, credits salvage with the sinking fund factor, and adds the yearly maintenance. Read the 8% 10-year factors. Capital recovery is 0.1490. Sinking fund is 0.0690. Pump A, 50,000 times 0.149 minus 10,000 times 0.069 plus 9,000, about 15,760. Pump B works out to about 17,125. Pump A is cheaper by roughly $1,300 a year, so choose Pump A. Its higher purchase price is repaid by lower running cost and bigger salvage. 3 traps. 1. Never compare unequal service lives head-to-head. Put them on a common horizon with the least common multiple, or use annual cost, which compares per year. 2. Don't confuse book value with market value. Book value is cost minus depreciation, a ledger figure, while market value is the real sale price, and each belongs in a different cash flow. 3. Watch the signs in incremental analysis. The increment is higher cost minus lower cost, so time zero must be negative. Reverse it, and the incremental return is meaningless. Set the problem up carefully. That's where it's won. You can now compare projects 3 equivalent ways: present worth, annual cost, and incremental rate of return, always over equal service lives. You can depreciate the winner by straight line, declining ballots, sum of years digits, or MARRs. And you can find break-even, where revenue finally covers cost. Today, Pump A won on annual cost at about $15,760 against Pump B's $17,100. That closes the economics pair. Last topic's factors, now turned into decisions.
The full study guide, with every equation and common exam trap, is free at peprepengine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.